Hello, and welcome to Kaman Corporation, based right here in Bloomfield, Connecticut. My name is Ian Walsh, and I'm the Chairman and Chief Executive Officer. I am super proud today to introduce to you a brand new, game-changing technology for our warfighter. And as a former warfighter, I can tell you, this is going to be a new capability that's going to meet the needs of all of our services. Let me start where it began, which was listening to our customers and truly understanding their needs, their requirements, and trying to solve their toughest problems. So today I'm proud to introduce to you KARGO UAV. The premise of KARGO UAV is around affordability, maintainability, and reliability. Our engineering team has worked in a very short period of time to design, test, and fly this brand new technology. I'm going to turn it over to my team right now to walk you through the differentiators of this in-the-box thinking and the other capabilities that this brand new UAV capability will bring to our warfighters.
Well, hello everyone. My name is Raman Dasmalchi. I'm a director here at Kaman Aerospace, and I'm a proud member of this KARGO UAV team. What I'd like to do now is show you a little bit about the KARGO UAV. As Ian mentioned, we like to say you have to think in the box to solve some of your logistics problems. Well, this is what KARGO UAV looks like when it's fresh out of the box. As you can see, it folds up into a nice tight form factor. This was designed from the ground up to fit inside of a standard shipping container. So a typical ISO container that you might see on a commercial ship or in a port facility somewhere or on a military ship. It's less than 8 feet wide and less than 20 feet long. So you can imagine this is quite a versatile size for this type aircraft. So the next step in operations for KARGO UAV is to get it flight ready. So we go from what we call the full stow configuration to flight ready by simply moving out 4 booms and locking the rotors into position with some very simple pin placements that my colleague Luke is demonstrating right now. The idea being that KARGO is designed from a clean sheet, designed to really be operated by very few people. So we don't want an entire maintenance department responsible to keep this aircraft in the air. We want the Marine or the soldier or the sailor that we're trying to service to be able to operate and maintain this when necessary. As you can see, as we walk around KARGO UAV, you'll see a conformal pod attached to the base of the UAV. We think this is probably the primary means for moving cargo across the battlefield, but you'll also notice that we have our typical external sling load. Cargo will be capable of lifting up to 800 pounds, whether it's inside that conformal pod or whether it's in a netted configuration like this, slung underneath the aircraft. We like to say at Kaman, we build things simple by design. The idea is to use high TRL components, things that we know work, and things that we can put into the field in the very near future. One thing we have not talked about to this point is the autonomy technology. I'm happy to say we're partnered with Near Earth Autonomy, a name brand in autonomy for logistics for this type of application. What I'm holding here is what's known as the Peregrine Autonomy System. This is representative of the same technologies that will be used on KARGO UAV. It's a LiDAR-based technology. It has all of the processing power required, and we'll be integrating this type of system onto the KARGO UAV platform so that we can provide obstacle clearance, even GPS-denied type operations, as well as precision landing operations for the end user. At this point, what I'd like to do is turn over the discussion to our chief engineer on this project, Luke Iono, and I'll ask Luke to walk through some of the systems on KARGO UAV.
Absolutely. Thank you very much, Ron.
Thanks, Luke.
All right. So for a quick walkthrough of the vehicle, we'll start at the back. Behind this panel, you've got the engine compartment, which contains a conventional turboshaft turbine engine. This runs on JP4, so conventional fuels. That in turn drives the primary gearbox, which is under this top cover, which converts the single input from the engine into 4 outputs that go to the individual booms. At this point, transmissions then running down the length of the boom transmit the torque to the ends and drive the rotor shaft. This is all accomplished using conventional transmission technology. This is not a hybrid vehicle, it's not an electric vehicle. This allows us to, again, as Raman mentioned, leverage very high TRL technologies to immediately be able to provide capability to the end user. Once you're at the end of each boom, you have identical rotor systems, which are very conventional in construction. They are effectively conventional helicopter-style rotor hubs with a teetering degree of freedom, as well as collective pitch controls. Those collective pitch controls are driven by electric actuators, which are controlled by a fly-by-wire system. Again, I want to emphasize that all of these are very much based on proven technologies that we've tailored to fit the unique application that the customer has in mind.
Luke, a question about the power plant. You mentioned proven technologies. We've elected to go with a fossil fuel burning turbine engine. What are your thoughts on upgrading or future-proofing this aircraft? Are we ready to install a hybrid electric, for example, or an electric system?
Absolutely. When such a power plant reaches a maturity level where it would benefit the end user, we're absolutely in a good position to be able to integrate those technologies into this air vehicle platform. That also goes for other emerging technologies that, at suitable levels of maturity, will be easily integrated into this system.
Okay. Well, thanks very much, Luke, for the description
Absolutely.
on systems. Obviously, there's a lot more to learn about cargo. If you're interested, please contact us here at Kaman Aerospace. Again, I would just like to reiterate, some of Ian's words in the beginning. This is really about, affordability, maintainability, and really suitability for the end user. We are developing something that we believe the warfighter can use in the very near future. This is not an aspirational, far horizon type technology. Again, we want the operator to take this out of the box, and within minutes it should be ready for flight operations. It should also be integrated with the whole ecosystem of unmanned and manned systems that they're going to support these future operating concepts for our warfighters that are forward deployed for all of us. So thanks very much for your time today. I hope you enjoyed our presentation, and again, we're available for any questions.